3.8 billion years ago, our solar system was getting hit by 1,000 rocks every day. Close your eyes. Now rewind time 3.8 billion years into the ancient past. Earth is just 1 billion years old. The sun is younger, and planets look entirely different. This violent era in cosmic history, unofficially known as the Late Heavy Bombardment period. Using modern planetary science and lunar crater data, we can accurately rebuild each ancient planet. Get ready, because our solar system was once a completely wild and violent cosmic frontier. Number 1. Mercury. Back then, Mercury was already small, dense, and heavily rocky. Its delicate surface was being relentlessly pummeled non-stop by massive cosmic asteroids. Giant impact basins constantly formed, and dark lava flooded the fresh impact craters. With no protective atmosphere, extreme temperatures swung over 600 degrees continuously. It looked like a massive, dark gray cannonball, completely covered in fresh cosmic scars. The colossal Caloris Basin, 1,500 kilometers wide, was created during this violent era. Number 2. Venus. Believe it or not, ancient Venus probably possessed deep liquid oceans. Because the early sun was slightly dimmer, temperatures allowed surface liquid water to remain stable. However, continuous intense asteroid impacts violently boiled these primordial oceans repeatedly over time. Thick steam atmosphere accumulated while thousands of massive volcanoes erupted across the planet. Ancient Venus looked remarkably like a scalding hot, cloudy, and highly volcanic twin of Earth. The devastating runaway greenhouse effect began right after the heavy bombardment period finally ended. Number 3. Earth. Our young planet Earth was hit harder than almost anywhere else. Our nearby moon is living proof. Its ancient craters reveal the exact sheer scale. Earth possessed liquid oceans already, but the planet's surface was constantly broken and violent. Vast magma oceans glowed everywhere, alongside non-stop asteroid impacts and 0 solid continents. The early atmosphere was a thick orange haze filled with toxic volcanic gases. Yet deep underwater, near volcanic hydrothermal vents, the earliest microscopic life was quietly beginning. Ironically, this extreme planetary chaos may have provided the exact energy required for life. Number 4. Mars. 3.8 billion years ago, Mars looked surprisingly Earth-like. It possessed active flowing rivers, vast freshwater lakes, and a massive northern ocean. A much thicker atmosphere insulated the planet because our young sun was active. Colossal shield volcanoes like Olympus Mons were just starting their gigantic historical growth. The climate was chilly yet wet, combining red rocks, deep blue water, and clouds. If you stood there back then, you would witness a breathtaking desert planet overflowing with liquid water. Number 5. Jupiter, Saturn, Uranus, Neptune. The gas giants had already fully formed. Immense gravity from Jupiter and Saturn shifted planetary orbits and hurled asteroids in every direction. That gravitational disturbance is precisely why the inner planets suffered heavy bombardment. Ancient Jupiter appeared similar to today, but vastly stormier, packed with raw kinetic energy. Saturn stood completely bare. Its famous majestic planetary rings likely did not exist yet. All outer gas giants were noticeably brighter, hotter, and actively settling into final positions. Number 6. The Moon. Our moon is the ultimate key to understanding this entire history. It has no atmosphere, zero water, and no active plate tectonics to erase history. So every single crater from 3.8 billion years ago remains perfectly preserved today. When we look at the moon, we are examining a pristine photo album of our early solar system. It stands as a permanent scarred diary of what every planet endured in that ancient era.
$3.8 billion years ago was a world of fire, water, ice, and cosmic chaos.
And directly out of that chaotic forge came the majestic planets we observe today. Which ancient planet would you want to visit back then? Leave your comment down below. Subscribe for new weekly space science videos. To understand today, we must look at yesterday.